of safety. This is the first in the series of 3 webinars. This first webinar is looking at the risk areas and hazards that we're looking at. We are going to have some time for questions at the end of the presentation itself. If you have any long questions, we'll probably answer those separately in a written email instead to make it a little bit easier for people. My name is Ruben Caires. I'm a technical sales engineer for FAAC UK, and I've been with us for about 9 years. And my primary role is to support the sales team.
And I'm Ricky Weeks. I'm one of the sales managers here at FAAC UK. I've been with FAAC for around 9 years. I'm here today to assist Ruben and possibly annoy, but let's see. And if we move straight on now into the standards, back to Ruben, really.
Thank you very much. Right, the primary one that we look at is the machining directive. Essentially, this has been incorporated into the UK law under the Supply of Machinery in bracket safety regulations in 2008. And basically what we're looking at is when you, the installer, takes any gate and you fit automation to it, you're basically making a brand new machine and you take responsibility for its safety.
Okay.
Part of that is you need to create a technical file, gets done for it. And the other part that we do, you have to get done is you have to have a CE mark, just like that one you've got.
What?
CE mark.
Yeah. Right here.
Yeah.
This is just an example. This is art, but you can create your own, yeah?
Exactly, yes. It just has to be somewhere on the finished article itself. And lastly, the main thing you really have to make sure you do is you need to issue a declaration of conformity to the customer. That is a key point there. Following that, in order to help with the machining directive, we have the relevant standards. The first 2 are the ones we're going to be looking at ourselves here, which is BSEN 12453 and the 12445. They're the actual requirements and the test methods. We'll actually look at the test methods in a later webinar. The second 2 is BSEN 12605 and the 12604. They are to do with the mechanical aspects of the gates themselves.
Yep.
They're not something we ourselves, in fact, are in charge of. It's mainly for installers. It's mainly things like making sure that the gate is strong enough and robust enough to be able to be automated in the first place. The last standard we see on the slide is the BSEN 12978. That is for us. So, you know, when you sell all of our safety equipment.
Yeah, so we're looking at inherent safety and...
Exactly.
Okay.
The test methods, you know, the things that people refer to Cat 2, Cat 3, performance level C, D or E. It's all of that. That's we get involved in, and all the things we sell. We generally have that little bit on the documentation, so we're covered by that part. We move swiftly on from that bit. We are looking then into the different types of hazards. So if we look at the type of hazards, these are the things we're going to be looking for.
Okay.
So primarily, the first 2 are always obvious. You always have a impact. That's where you get hit by the gate at any point during this travel.
Yep.
You then have crushing. You've got crushing where obviously the gate closes up against a post or opens up against a wall, anything like that.
And this is on the leading edges of...
Generally, yes.
Here, like the sliding gate, open and close.
Exactly. You also get them underneath the gate sometimes.
Okay.
But it's all dependent on where you've got there. We always have, not always, but you generally have a shearing risk. Exactly like that. You have the trapping, dragging. So that's essentially when you've got
this is
post. Exactly. Let me go through there. You then also have a cutting risk. That is essentially when you have a palisade gate going past the palisade fence, you essentially get a effective guillotine. Loads of little cutting risks all the way through. Okay. And lastly, you end up with a hooking risk. Those are all
gate furniture.
Yeah, gate furniture, handles, stuff like that.
And this way material can get trapped and drag you along.
Exactly, yes. And obviously, if we take these types of hazards that you're going to be looking out for and we incorporate them into the different areas. So if we go look into the areas instead, and we'll focus first on the sliding gates to start with. Okay. Primarily, we have over here this area right here. So this gate closes in this direction. So we're always going to have the impact. Okay, it comes along. If I release it first, okay, it comes along, you get the impact, and then subsequently you have the crushing up against the post. You're always going to have an impact on the opening side. So as the gate opens, you may or may not have a crushing risk. It depends on whether the gate opens against a wall or a return or something along those lines.
And this is where we do like force testing for the newtons, right? 400 and 1400 or so.
Exactly. Right? So impact 1400.
Yeah.
So whenever you have an impact risk, it's always 1400 as the maximum. When you're in a crush zone, or dragging, shearing, any of
It's
the
where
other
the
zones,
gate's closing up against something.
exactly.
Okay.
Or you have the shearing, then the forces drop straight down to 400 newtons to make it more better for somebody. Exactly. We also have the shearing between the sliding leaf and fixed parts. That is obviously, as Ricky demonstrated earlier, gate comes along, you get arm sheared. You've got the dragging as well in between the gate leaf and the post. So on here, you can get dragged through inside this area. You've got the dragging of the feet on the lower edge of the gate. So underneath here is something that you've got to worry about. So when you're looking at like the rollers, for example, if it's a cantilever gate, if you have a big gap, large low rollers, you have an area underneath. Ideally,
you have kind of got my job here.
Oh, well, I'm going to try. Lastly, dragging of hands on the drive unit. Usually you have finger guards, etc. get fitted to it. If we move on to the swing gates. Swing gates, we have this area over here. So we have the impact and the crushing on the main closing edge. So that gate comes around to close. You're going to get hit by it and you get crushed by it.
Exactly. So these are on the leading edges, closing, opening.
And you have the impact and potential crushing in the opening area. So that's a whole swept area that you're looking at. So as the gate moves along, you can obviously get hit by it and crushed by it. You've got the impact in the area of closing. So the gate always closes to thin air. Obviously you have the leading edge, but the rest of the gate is what we're looking at.
This area here.
Exactly, yeah. As the gate's closing, you have an impact generally at least. We then have the dragging and crushing of hands on the hinge side edge. This is where we're looking at over here.
And this is vital, right?
This is the vital one, somebody to look at. If you're doing retrofits especially, it's something you really need to take into consideration while you're doing on it. There are some safe gaps which we're going to be looking at a little bit later to give you some bit more detail on this point here.
So what we're looking at for the protection on the hinge point, when ideally you're trying to lose that risk,
ideally you design it out, so you remove it. If that's not possible because it's an existing gate, then you're trying to use, for example, safety edges on the gate, like active safety edges, so they are responsive. And lastly, if none of that is possible, you may only be left with using a finger guard.
And what's that gap there that you've got?
We're usually looking at, in terms of the gaps, which we'll look a little bit more detailed later, better. You're looking between 25 and 100 mil.
Okay. But
when we go into that particular slide, you'll see it a little bit easier.
Perfect.
Then lastly, you've got dragging of the feet on the lower edge of the gate. So that this gap underneath the gate, we have something that we need to look at there because you might get dragged and crushed.
Yep.
Obviously, if the gate, is quite low down to the ground and you get your feet trapped underneath it. You've got the dragging of hands on the drive unit itself.
Yep.
Ideally, that isn't something you generally should be too worried about most of the time because we have the covers and assuming you fitted the motor correctly, it's not.
There's no gap. It should reduce there.
They should reduce there anyway. It should just be moving along as it goes through. And lastly, you get the dragging, hooking, cutting due to the shape of the mobile leaf.
Yeah, okay. So again, this is accessories, gate locks, fannibles on the top, spires.
That kind of stuff. They're all the ones that you can get hooked on. And they are the worst to try and get around. There's not very much we can do with those besides using lasers. And we head back out of this. And we now look at the safety distances first.
Okay.
So essentially, primarily, most of the safety distance we're generally looking at is the 500 mil. That's the one that everyone knows generally refers to. Essentially, if you don't have an obstacle within 500 mil of the gate.
So this is where if the gate was opening onto a wall.
Exactly.
If that gap's 500 mil.
If it's 500 mil or
the risk
more,
reduces.
The risk reduces. You're only looking at the impact area
and
force, which is the 1400 newtons again.
Rather than the crushing.
Rather than the crushing, when it then rolls down to 400 newtons. And it's exactly the same thing with a sliding gate. Obviously, you can see on the example that we have here on the presentation, obviously you have the impact zone at the back, and then you have potentially a crushing zone.
And this is
if you have something there on there. And you can also see on there the draw in and the shear. So that's in between the gate and the post.
Yeah.
If you get it to within 8 mil, you have no drawing or shear risk because you can only get like fingertips inside.
This is it. So you're talking about this point here.
That point there.
Okay.
If it's bigger than that,
Sorry.
then it's a drawing and a
That's
shear.
fine. It's this dragging.
Yes,
So
that
this
dragging
is
is
reduced to 8 mil, and then it loses that risk.
loses the risk, which elimination is always better than a risk reduction if you just get rid of it. And if we then look into the hinge gaps instead, or the hazards covered with the safe gaps, what I meant. If we look first at the top one, the over 120 mil, this is really primarily for swing gates.
Yeah.
The same is applied on sliding gates as well. But if you have a gap underneath the gate of over 120 mil, and it's constant throughout the entire swept area, generally the chances of a crush risk are greatly reduced, and you get left with the impact. So essentially the impact of the gate hitting you.
And those forces always remain the same. So it's 1400 and
400, exactly that. So as you can see on the slides, you can see within the impact zone we have 1400 newtons.
Yeah.
Within the crush zones we then have 400, and you can see them around in different areas depending. If you go and look for gaps under the 120, essentially we have a gate that has a slope.
Yeah.
So if you have this sloping gate coming in, we then basically have a greater risk of
any
crushing.
like rising driveway or
Rising driveways, anything like that is more problematic. At that point, the maximum amount of force is 400 newtons.
Okay.
And in general terms, we're looking to use,
because again, it's considered as it could be a crushing hazard
Exactly
rather
that.
than just the impact.
exactly. So it's a greater risk, and we're generally looking to use safety edges or laser curtains will get fitted to it.
And the laser sensors actually move.
Yes, they will move
the
the door.
entire gap,
So, on the swing gate, you have one on the inside on the top corner, by the hinge point, one on the outside, exactly the same position, and they move with the gates.
So that's protecting your sweeping area, but you still need to protect the hinge point.
You still need to protect the hinge point.
Okay.
Sometimes the laser can do that for you. It's just down to how your distance is. Like that. And obviously you've got safety edge that normally get fitted to it as well. Not as well as the X guards. You either fit X guards or safety edge. Yeah. And if we go for the hinge gap area, so like I was saying earlier, ideally you redesign the gate if you can, so it's like a zero gap change hinge. That's the ideal scenario. But obviously that's not always possible. So that's where you need to put a safety edge finger guards. But it's always worth making a measurement of it.
Okay.
So minimum gap 25 mil, max gap 100 mil, and as long as it doesn't change by more than 20%.
So the reducing gap is less than 20% when it's opening.
Exactly, we're fine. You're not going to be not great risk.
That's not considered a.
Yeah, it's not considered a crushing risk anymore.
Understood.
And obviously, if you take all this information together, and then we're going to be going into like the process of doing it. And ideally, let's look at the risk analysis process first. So you take all the information we've just been going through. You need to obviously identify and make a list of all the possible hazards.
So these are ones we've already ran through. So we've got the shearing, crushing, trapping, dragging.
And you try and resolve as many of those hazards as possible by the application of the safe designs, like zero gap hinges or
like a mesh on this gate, which
Exactly.
eliminates the shearing point.
Exactly. Just doing that, you've automatically got rid of all your shearing risks along the gate.
So you got rid of the shearing, but you still got the.
You might still have the dragging. So if you
unless
can bring that post,
gap to 8.
exactly, then you're fine, and then you just get left with the impacts to deal with. Then obviously wherever you get left, you obviously try and apply the latest state-of-the-art system, safety
Technology,
lasers, etc. Get fitted to it. And you have to identify all the remaining minor residual hazards you get left. That'll be like trip hazards on the gate, and obviously get to use instructions and do all the maintenance and really make a note of those documentation. So if we go out, the process flow of how you do it is as you describe, and you're basically creating like a big feedback loop. Ideal goal is design it out. Secondary, then you go in, can you fix it?
It's all part of your risk assessment.
Exactly that. And if we then go back out, you got to then make that recorded somehow. There's an example here we have as a tabular form. So you make a note of the risk. And even if it's something as simple as like you see on the second one, where it's got crushing and trapping between the hinges and the gate, although the solution is going to be we're going to relocate the hinges, you still make a note of it.
So this is the same as what we've got on our handout manual.
Exactly.
And that's available online, right? So
Yeah, you can just download it from the
it,
website.
use it, and that gives you risk hazards to look at and logging as well.
Yeah, exactly. So it gives you all that information there. And if we go back out that one and we go into you get left with, if you do all the other stuff, like you put the mesh, you bring the post down, you get left with the main leading edge. What do we need to protect it?
Main leading edges, so
exactly
every
that
point where you've got that impact.
And it is dependent on how you control the gate. If you use a dead man system where the informed users are actually, somebody's actually using it.
But that's where they've physically got to be holding a button down as such through the whole movement of the gate.
Yes, they have to control the entire movement all the way through.
So as soon as they take it off, dead man
gate stops. Yeah. And just remember, they always have to be able to see the entirety of the gate.
Yeah.
For it. If you can't do that and you go impulse control, so you press a button, the gate moves in any way by itself.
So it's a semi-automatic where it has
Semi-auto.
to go through the process.
Yeah, that's when you then click the safety edges, presence detection by safety edges, force limitation, or the lasers can get used for it as well.
Okay.
And then once we go out of that one, we then get left with the residual risks. So remember I was saying about the trip hazards, they're highly likely, not very common, not very dangerous. You can change them. For example, on a sliding gate we have a trip hazard, but we could take that trip hazard out by making it into a cantilever gate.
Yeah, but where you can get rid of it, you're recording those risks, and then you're making the end user as such aware of them.
Yeah, and there's different ways of doing it. You can do like ground markings, reflective materials, for example, if it's trip hazards, signage, information. It's all about making sure that if there is something you can't remove, like a gate stop,
physical stops, and anything like we say, the rail.
That's where it comes in, and that essentially pretty much brings us over to the end. Now we get left with questions. So hopefully we might see if we have any questions.
Hopefully not.
Well, we'll see. They're on there. So is there any questions that we can see?
We had a question posed earlier by an installer. Is bracing something that has been recently added to standards?
I think when they talk about bracing, and this is probably one of the most common questions I get asked recently because it's been upgraded within the DHF documentation and such. So, and it's all regarding the actual safety of the gate. So where it's not, it can break the hinges, fall off, and how do you get around it?
Yeah, that's all it essentially is. It's just basically, it's just making it more clear to people that that's how it's supposed to be. We're looking at essentially like the hinge positions. Obviously, on here, when you're doing a retrofit on the existing gate, you need to make sure you inspect the hinges, which are solid.
If your hinge is like this, they're kind of ideal.
If they're both pointed up, then essentially, they're both holding the weight of the gate.
Yeah.
But it's quite common here in the UK for you to have one hinge at the bottom pointing up, and one hinge at the top pointing down, which is so you can't, the security so you can't just remove the gate. Problem with that is the bottom hinge breaks, your gate falls off.
And it's really gates falling off.
They are the greatest risks, and the more recent news articles have highlighted that, especially on sliding gates, where there were no physical stops fitted. So, they might not have ideal bracing on the gate at the top. So, the rollers.
So, if we're looking at this, if you had the post there, you were safe, really. And with this sort of thing, you're looking for something that can retain the gate should this break.
Exactly. So, you've got multiple points there to obviously keep the gate in place, but also when the gate's rolling along, the gate
shouldn't be able to roll past.
No, shouldn't be able to roll off. That'll be quite a bad thing if that happens. We'll just see if there's anything else.
Somebody has asked if it's possible to receive copies of the information slides used in the presentation.
Yes, of course. We'll be sending that through over to you without any problems at all.
And we will have a recording of this available as well to download.
Exactly, yeah. If that's all the questions, then essentially, thank you for your time. And we look forward to seeing you all on our second webinar, where we're going to be looking at force limitation. We're also going to be playing around with a force tester, and also looking at the X cards as well. And this is the same time on the 30th of October. Exactly. We're asking questions. Yeah. So that's it. Yeah. So thank you for your time, people. Yeah, thank you. Cheers. Bye.